Oh, don't do that. That would hurt. Yeah. Well, I guess a hot potato would feel just as bad. So yeah. All right, guys. Let's do a warm up really quick. So I guess partner up with somebody that you can work with, and then find a space on a whiteboard. If you can't get the whiteboard, there's whiteboards all over the wall. Oh yeah, Indigo. You should do. Okay. Find someone. Funny. Okay. I'm just kidding. You don't have to. But try to recall how to do this. It's not the easiest. You can look up how to do this on the internet. I want you to try to complete the square. What's up? I'm sorry. Solve this problem. Solve by completing this square. It's not an easy problem. I think it's pretty tough. I think this is not an easy question. Of course it's not easy. Well, it's a warm-up. I don't want it to be too hard, guys. Yeah. If you don't know how to complete the square, how did you do that? So, let's see. You added... I'm sorry, so it's...
That's how it showed it in the book to complete the fire. I hope that's right.
I think you're skipping some stuff.
Yeah. But I get the 2 because you're supposed to take E.
I'm sorry. So this is... And you add that on both sides.
And then yeah, right.
Yeah, the square is pretty tough, so that's why I know this chapter. For sure, I want to remember it. So that's why I want partners. So like yes, you are. Yeah. Now just factor it out.
Oh, plus or minus 4. Yeah.
Two.
Sorry, I'm late.
All right. By like 10. That's really cool. That's really funny. Here, I have your exam, Ava. Month 2. I have not graded your retake yet.
Okay.
Yeah, I gotta give it some time. Very good. All right. Let's see. All right, guys. Why don't you guys have a seat after you guys are finished? Explain it to each other. Help each other out by explaining it.
I don't know if I did that right. Yeah, you should.
No, you don't.
No, I didn't.
You're fine. Yeah.
I remember the one formula we need.
Fayad. Sorry, I don't have your test graded yet. So.
Yeah, I realized.
Okay, so let's go ahead and go through this. Actually, Fayad, I don't want to keep making Indigo do it. Can you get the lights? Because Indigo's always closest, but I don't want to always make her the default person that closes it. She's retired. Yeah, temporarily retired. Okay, so what we're gonna do, the first step. What did you guys end up doing for the first step? Yeah, go ahead, Catherine.
We subtracted 12 and moved it to the other side of the equation. We have to write this.
No, this is more for just notes for like people that don't remember how to complete the square. So I would suggest you do if it's not like perfectly memorized. It's not. I don't think it's super intuitive. Okay, so I would have taken notes for sure. Okay, because I don't remember all this stuff. Okay. So now we have x squared minus 6x is equal to 7. Anybody else want to tell me the next step that they did? Yeah, Luciana.
You find I forgot what it's called, but you basically take b over 2 and square it.
Okay, so just remember that this is A is 1, B would be technically 6, and C is 7. It's just on this side, but we're going to focus on the B. You're going to take your B and divide it by 2 and square it. In this case, our B is negative 6. Again, that negative doesn't really matter so much because once you square the negative or square a positive, it's going to go away. It's going to be a positive number anyways, okay? So when you take your negative, or you take your B, it's negative 6 divided by 2, which is, that's correct, and you square that.
Which is 9.
Okay, what do you do with that 9 now?
You add it to both sides.
Okay, very good, both of you. I know what's going on in your head, okay? So this is where we call completing the square. Why is it that we add it to both sides? Yeah, Fayad?
When you do anything to equation, you have to do it on one side to the other. It's to make it fair. Like if you have 2 houses and if you give food to one shelter, you have to give it to the other shelter.
Let me ask you a question. I know that we're completing the square to solve this problem, but when you complete the square, when you add 9 and 9 to both sides,
you don't subtract it back to the other side because then you'll get it back to the first. You're gonna get it back to the first.
I was just gonna ask, do you actually change the value at all when you add 9 to both sides?
No, it's supposed to be equal.
So I mean, like intrinsically, if you add 9 to one side, you are changing its initial value, right? But it's an equality. This is an equality statement. So if you want to make this statement still true, you have to add 9 to the other side, okay, to keep this intrinsically the same thing, okay? So I'm sorry when I say value. You are actually changing its value. You're increasing the value of the left side by 9. But if you want to make the equal statement still an equality statement, you have to add 9 to the other side to keep both statements equal. Does that make sense? Okay. All right. So let's see. You have this here. Now what? What was the whole point of this? I don't. Factor by grouping. How do you do that? I don't know.
So we did a perfect square, so you could just do a plus b whole square, or a minus b whole square. In this case, it would be x plus a is the x and the b is 3 square, so it would be a minus x minus 3 square equal to 6. That's another way to do it.
Okay, that's one way.
Get the same product.
I want to keep consistent with what I showed you on the videos and stuff, though.
So you want to do it by grouping?
Yeah, let's do it factor by grouping then. Yeah.
Okay. So
Actually, I'm sorry. So, no. Since we are, I apologize, Luciana. Since we are completing the square, it would be actually more consistent if I showed it this way because you guys are going to have to know this method later on. You take the b over 2 statement that you have here, which would be, what is it? It'd be negative 6 divided by 2, which is 3. Okay. And then you have 2 binomials with this statement because all you need to do is you need to take the b over 2, or the b statement divided by 2, and then you need to combine it with an x, and then you have 2 of those values. That's kind of the beauty of completing the square. You have a binomial that is essentially squared now because of what you did here. That b minus 2 allows you to do this statement down here, okay? Is that it?
no.
Did we solve for the x value at this point?
No.
Okay, so what now?
You square root both sides of it. No.
Very good. What is the square root of 16?
4.
Yeah.
Plus minus 4. You have to do plus minus because of the square.
Be very careful. That's very true. Yes. Good eyes. Okay. And then you have, since you took away the square statement here by taking the square root, you have x minus 3. I'm sorry. Now what?
You do your 2 mini equations of plus and minus. Like x minus 3 is 4, and then x minus 3 equals negative 4.
Oh, okay. So you can do it. Like you were talking about. X minus 3 is equal to plus 4. X minus 3 is equal to negative 4. Or if I add, I think you were going this way. You add 3 to both sides too, right?
Yeah.
Either way works. It's essentially saying the same thing because eventually here you're going to add 3, right? Yeah. Add 3 to both sides, and then this would get you. I'm sorry. I'll do an arrow. This would get that x is equal to 7, all right?
And -1.
And then this is x is equal to -1. It's the same thing. You might have learned it a little bit differently, but it's the same thing, so it's nothing different. Or in this case here, this is essentially the same thing because this is just saying you have two answers. Yes, Faya.
I have a question. So
Yeah.
So it's x minus 3. So how would you know if you have to put the 3 before the plus minus 4? How would you know?
Because even if you did do it the other way, it doesn't really matter, Fayad. You're basically saying the same thing. There's a case where positive 4 is being added to 3, and then the negative 4 is being added to 3. So that's a good question, though, because you would think in your head, you're like, wait a minute, does the order matter? Because it feels like it does, right? Because we're so used to seeing the operation in the middle, right? But it could actually be treated as two different signs, too. So it's really, really good inquisitive question. Okay, great. We need this skill to talk about some of the things that we're going to do today. Okay. Who recalls, before we begin this section, who recalls the basic, what we call the general equation for a quadratic, meaning this type of graph here? Like if I said this type of graph, I think you would recall that the equation for this is y. You have two ways to do it. Yeah, Indigo?
Equals mx plus b.
That's one way, yeah. And then the other way would be y minus y1 is equal to m times, because it's a line, right? Two ways, exactly. What about a quadratic, though? This is a quadratic.
Wait, isn't there standard form too?
That's what I'm asking for, is the standard form. What is the standard form of the equation? Huh? Go ahead.
The b squared, and then there's like, called the square root thing, and then inside is like b squared minus 4ac.
That's the quadratic formula. Oh, I'm sorry. So you're thinking of the quadratic formula, which sounds just like what I'm asking for. I'm asking for the general equation for. So the quadratic formula is, let me try to word this correctly for you. The quadratic formula, what you described, helps solve quadratic graphs. That helps me solve where it crosses the x-axis. That's what the quadratic formula is used for. What I'm asking for, though, is what is the general equation for just the quadratic itself, not the formula. The formula solves where it crosses the x-intercept. I'm asking for the formula that, the equation that explains just this line by itself. Okay. I know it's a really confusing way to word it, so I'll try to explain it a little bit better as we go along. Luciana, yes.
X squared plus bx plus c
is equal to 0.
is equal to 1. Well, no,
Why?
Why is it not equal to 0?
because it's not always necessary.
Wait, you're looking for graph or the equation?
Yeah, it'd be y.
This is very high level conversation you guys are having. No, this is good. Why is it that it's not actually equals 0, the general equation?
Because when you're graphing it, you have to it's my bad. When you're graphing, you have to use fx or y. But when you're actually solving the equation, then you use c.
And when you're solving the equation,
Yeah, like with the
what are you actually solving for? I think we're just used to saying that.
For the x-intercept.
Yeah, this actually is only when we're trying to find out the x-intercepts, because at x-intercepts, what is your y value going to be at the 0? So that's what you're actually solving for.
So it should actually be y or f.
Yeah, so in this case, if we're just talking about the general equation, we're not solving for the x-intercepts, you don't need that component, okay? So this is really good, guys. This is really awesome conversation you guys are having, okay? Again, if I was in school, though, I'd be the one student that's like, I don't know what's going on, but I'm here to just do the math, okay? So I'm actually really impressed that you guys are going a little bit beyond what I was capable of, okay? I think you guys are already aware of those. Like, yeah, we're a lot smarter, but okay, than you was, Mr. Wee, okay? I'll be honest with you guys. I'll be honest. I'll be honest, Mr. Wee. Okay. That being said, there are two ways to express a quadratic. No, I'm not. I got a microphone. Yes. You realize that when I just touch my cheek too, it's gonna be like when you guys listen to the video. Okay. Or actually, for the people that are gonna listen to the video, I think once you guys are done with this, I don't know if you guys go back to the video at all. I don't think you guys do. No. No. Oh God, no. All right, now we can begin some notes. 3-5, transformations of quadratic graphs. And here's the first set of notes I want you guys to take. I got to zoom in a little bit on this. And I'm going to go ahead and freeze frame this. In the video, it won't freeze frame, but for you guys, it will freeze frame. So, yeah, Indigo, what's up?
Isn't 3.4 translations of quadratic graphs and 3.5 is inequalities?
No, because Mr. Wheaton, when I was checking the solutions, you mixed up the order.
It was weird.
But in the book, in the book.
Oh no, just to let you know, I didn't make the solutions, guys, but I think I know what you're talking about. Someone told me that last year. Yeah, I'm sorry. So, I mean, guys, what I really mean is graphing inequalities. I'm so sorry. Yeah. Quadratic.
We first do vertex form, and D5 is vertex form.
Wait, no?
Yes,
That's
it
like
is.
Huh?
Yeah, I did 3.5.
Vertex?
Vertex.
Oh, I was like, what's a Ventex?
The Ventex. Yeah.
It looks like Ventex.
Yeah, this company Ventex made this. Yeah, no, I'm just kidding. It's the Vertex.
It's
So-
3-6
Good
is
thing you're a
inequality.
math teacher.
3-6 is inequality.
No. 3-5 is quadratic inequalities. 3-5 is quadratic inequalities. Quadratic inequalities. Yeah. Oh. Luciana.
What?
Come on, man.
Okay. Let's back up, guys. Can't believe we lost all this time over this. Okay. 3-5 is quadratic inequalities, but we're not doing 3-5 yet, guys.
My notes are suffering.
This is why I really enjoy having you guys. You're what I call a hoot. A hoot. Okay?
I love the blue.
Yeah, because I ran out of whiteout.
Bringing out the mistakes. We don't cover up mistakes.
Yeah, we don't.
We make the mistake.
Okay. So let's see. Yep, this is This is transformations.
Make sure it is.
I'm looking at the book right now, so don't worry. Transformations of quadratic
Are you sure?
graphs. Wait, I'm just kidding. I'm just kidding. No, we're good. We're good. We're good. We're good. It's transformations of quadratic graphs. Okay.
Are you sure?
Yeah.
Right in the beginning. Are you
We were right in the beginning.
positive?
The only change we needed to make was 3.4, not 3.5.
Are you kidding? So I can write it down and I don't have to.
If you're that one slacker right now, that's like barely like, oh, I just wrote the first thing you did, and you would have to do the least amount of work. Oh, I just changed the 4 to a 5 or 5 to a 4.
I didn't even start the notes.
Okay, now start the notes. Okay, if you can, go ahead and start the notes. I need to get more white out.
I don't know. That blue is really covering up. Is that is or in or
Where?
in? Written in.
Written in. Yeah.
It's like a backward S.
Is it okay?
I mean, we could talk like that. Originally, our quadratic formulas were written is. Y is equal to ax squared.
At least he's really good with A, B, and C. As long as he's good at that.
Alright, we have no more whiteout.
Did you use them all too much? Probably. Literally, I wrote it perfectly. Same. I put so much effort. No, I'm just rewriting. I wish I brought my erasable pen.
Okay, so as you're writing this, think about a line. There's how many ways you can write the formula of a line? that we kind of went over just now a few minutes ago. Yeah.
The 3, the straight line, the parabola, and then the exponential.
Oh, no, I'm not asking for the type of graph. I'm asking for like when you draw a straight line.
Like a linear.
Yeah, like a linear equation, like a line. How many ways can you write the equation? Like standardized ways.
3 ways.
There's 3 ways.
Yeah, isn't there? 'Cause there's
Okay, let's
MX
just.
plus B, and then there's
No, that's for wait. You talking about all of them?
those are the graphs. Those are the different forms.
Oh.
Just for the graphs, or are they?
Yeah, I'm just asking for a line, just for a straight
Oh,
line.
parabola and exponential.
No, I'm not asking for like the different types of
No,
graphs.
but-
That's correct.
No, but like for linear, there's the standard form.
Which is
So there's y equals mx plus b, and then there's the y equals
Point slope.
y.
well, I want to hear from Petunia. Petunia, you have your hand up. What else?
So that's a standard form. Y is equal to mx plus b, and then you have a point slope form.
Uh-huh.
Y is equal to parentheses y1 minus.
I see. Y minus y1, you mean?
Sorry, y. Yeah, y1 minus y is equal to x parentheses m minus x1 and close parentheses.
Wait, no.
X minus x1.
I'm confusing that one with the.
All right, guys. I'll just write it out right now. Okay.
Yeah.
Guys. This is a.
Equals.
Yeah, I said that.
You have this way, or you might have it where m times x minus x1 is being added to y1. Is that
No, we didn't learn that.
you didn't learn that? Okay.
No.
So it,
It's like
but
No, it's that one. I said that. But except for Petunia, you said it at the end. I
those
said
are
it
the
at the
two main
beginning.
ones, but I know there's another one.
Yeah, it's like there's.
Mhm.
My brother had it on his test yesterday.
oh, nice. All right. Well,
Who's that third one?
my point being is that there's like 2 ways you guys know of it, right? There's multiple ways.
He's like,
Because it's
Hold on. Hold off for just 1 second, okay? So with quadratics, there's also 2 ways. You've learned about this is literally called this is standard form. Another way of doing this that we can utilize is what's called the vertex form, okay? And what is its main application, or what is so useful about vertex form? Okay, Catherine.
finding the vertex of your line.
Yeah,
Your parabola.
yeah. It's
You're adding more letters. This is more complex.
it looks more complex, but when you use it, when in practice, it's going to be really nice. So A, H, and K are just random numbers. They're constants.
That's
Okay.
okay.
Yeah, that's it. That's that's a K. Sorry.
Where'd you put
Okay.
that? It's a 1 and a C.
The way this is written is the vertex is just given to you right there. If you know what the H is, just keep in mind that H is being subtracted in this case. So if you see x minus 3, for example, what is your H value actually going to be? Yeah, it's positive 3. Correct. So be very careful with that. But given this is all you have to do to find the vertex. And at the same time, if you think about it, your H also gives you what other type of feature that you can look on any parabola. Indigo,
Doesn't it tell you what the x value is?
which x is equal to
Yeah.
H, but what is that? What do we call that? Go ahead. The axis of symmetry as well. So there's a lot of things that we can gain from this by doing nothing. So like, don't write this down, but what you're used to doing to solve for the axis of symmetry before, or I'm sorry, yeah, for the axis of symmetry, what you would normally have to do is you would have to take negative b divided by 2a to get x. And then to find the vertex is even more complicated. That was a coordinate, negative b divided by 2a. You would have to plug it back into the original equation and then get like some kind of y value, okay? You no longer have to do that. With the vertex form, as long as you can get your equation into vertex form, that's it. This basically tells me my vertex. H by itself just gives me my axis of symmetry. It's beautiful. Whoa, it's beautiful.
Wait, why would it be positive? Like back to the H thing, if you said it was at 3, why would it be positive and not negative? Like if it was minus 3?
Oh, because H is always going to be subtracted. So whatever your H is, it's always going to be subtracted from it. So if you see x minus 3, your H value is actually a positive number. Do you see what I'm saying? So I think give me a few seconds to show you an example, and then hopefully it'll be a little bit easier to understand. So here's your first set of notes. or sorry, not your first set of notes, but your example. Here's an example. Let's rewrite y is equal to x squared plus 4x plus 6. This is in standard form. But we're going to rewrite this in vertex form.
Do you go on the board?
Not yet. Not yet. Let me guide you with this. Maybe you guys can help kind of guide me to how to figure this out. But we basically have to get this to look something like this. Y is equal to maybe a number on the outside, x minus another number, squared minus plus another number. Don't write this down. Don't write this squiggles down, okay? The squigglies here. I'm just saying eventually you have to go from here to here, okay?
Well, A would be 1, wouldn't it?
What's up? Don't worry about the A or anything for now. I'll show you a case where you find out the A. But the first thing you need to do is you need to group the first two A and B statement here. And then kind of look at 6 as almost a separate entity, even though it's still being added, okay?
I mean, it kind of is.
And then what you want to do is, this is just a procedural method. You kind of want to leave yourself a little bit of space here. And here. Notice that I have an addition and a subtraction here, okay? Let's put that in parentheses over there. X squared plus 4x in parentheses plus 6 minus whatever that number is, okay? We're going to fill up these empty spaces. Yeah, Sophia, did you want to? Okay, so you got 2. Where did you get 2 from? What are you doing to get 2? It's completing something. You're completing something. Okay, so in order to do this and get this in perfect vertex form, we need to utilize the method that we know to complete the square. Okay, there's a very specific reason why. So we're going to take our b divided by 2 and square it. Our b in this case is 4 divided by 2 squared. 4 divided by 2 is 2. 2 squared is
4.
all that work just to get 4. Okay, but it's good. Okay, it's not always going to happen like that. Okay, I guarantee you it's not always going to happen. So before, when we completed the square, this number, like plus 6, was actually on this side of the equal sign, right? So what we did was we added 4 to both sides, okay? But notice the 6 is not on the other side. It's actually on the same side. So we don't... Yeah, you have to add and subtract 4. Why?
Because it's supposed to be on the other side. So it has to be equal, so you have to make it so that it cancels each other out.
Yeah. So like before, we were adding 4 to both sides, and just as easily, if you subtract 4 from one side, you'd have to subtract 4 from the other side, right? So in this case, it's like we moved the number, like the 6, what should be there, we moved it over here. We also added the 4 that used to be a subtraction, like it would be a minus 4 on this side. We put it over here, or I'm sorry, it would be a plus 4 on this side. We would have to subtract that 4 from this side, and that's what you see here. Another reason why, which might make a little bit more sense, is are we trying to change this value at all? Are we trying to change the inherent value of this equation? No. We're only changing the way it looks, right? So sort of like when you did y is equal to mx plus b, and then this form here, y minus y1 is equal to m times x minus x1. If you do 2 forms of the same equation for any line, okay, you should have the same thing. They should still retain the same value, okay? They're just 2 different ways to express an equation for a line, right? This is the same thing. We don't want to change what's kind of already here. We just want to change the way it looks a little bit, okay? But we don't want to change the value. If you just spontaneously added 4 to that, you changed the value. You increased it by 4, okay? So yeah, and like if you had a number on the other side, okay, I get it. You would add 4 here. You'd also add 4 here to keep the equality going here. But that's not the case right now. We just have. I'm sorry, what?
On the other side would be plus.
If it was on the other side, it would be a plus 4. Okay. But on this side, since everything's on this side, we just want to retain the value. We add 4, we subtract 4. What are you actually adding to this if you think about it? It's a fancy way of adding 0, right? Because plus 4 and minus 4 cancel each other. Okay, so that being said, we have this here. So now we have x squared plus 4x plus 4. And then let's have 6 and no, sorry, so sorry. Plus 4 minus 2, that's essentially 2. This is looking a little bit more like the vertex form we want, huh? Isn't it? Isn't it? But is it good the way it is right now? No. Oh, Hassan's like a fat no. Okay. What could we do to this to make it look more like vertex form? Okay, Sophia, do you want to go for it? Yeah. Well, it would actually be the close, very, very close. Okay, you're on the right track. Yeah.
X plus 2 in parentheses squared.
Okay, so let me write the general way first. You take what you had b divided by 2. Okay, your b divided by 2. You square it, right? Plus so this is completing the square plus 2. In our case, our b over 2 was 4 over 2 or just 2. Not b over 2 squared. Not b over 2 squared. Just b over 2. Our b over 2 in here, b divided by 2 was 4 divided by 2. It's just 2, okay? It's not 2 squared, it's just 2, right? This is very tricky. Okay, Hassan, did you want to add something else? Fayed, sorry, I keep. Yeah.
Okay, my last name's Hassan.
I know.
So that's confusing because in the beginning of the year we learned that a squared plus 2ab plus b squared is equal to a plus b whole square. So if you do the b over 2 whole thing, it's kind of confusing because we already know the formula. A plus b whole square is a squared plus 2ab.
Oh, okay. So
If you just take the first and the last term and then square root and then because it's confusing what you did b over 2.
does everybody feel the same way?
I have no idea.
Yeah, I don't think everyone's following along with what you're saying.
Well,
But yeah.
in the book it said a.
I understand. But just bear with me. If you know both ways, Fayed, then it's more power to you. But I don't think everyone can kind of relate to the same problem. Maybe some. Like I can envision a few people that are like, when you're complete independent study and you learn it like the first way, you can stick to that way too. But if you're this good at math, Fayed, okay, try to give yourself a challenge and try to see it 2 different ways. Okay. All right. So at this point, what is my vertex? This is very tricky. What is?
The vertex 2 and 2. Wait, is vertex the negative? Wouldn't it be negative 2 because it's plus 2? Because remember, it's the inverse.
So think of it this way. If you remember vertex form is always written as x minus your h. So secretly, if you want to rewrite it the right way, it's technically x minus. And if we have a plus 2, we have to rewrite this in the same way so they're equal. It's technically minus 2. That tells me immediately that my h is secretly negative 2. Does that make sense? The standard way to write vertex form is x minus h. So,
But where's the a then?
oh, what is a right now in this case?
It would be 1.
Yeah, Indigo?
1.
It's just 1 for the time being. You're going to see a situation where a is not 1. Okay?
No.
Trippy, huh? Now you guys got to do one.
On the
Okay.
board.
On the board. Okay, so hold on.
Scared.
Okay, let me give you a problem now. So here's your problem that you're going to do. try this one. It's y is equal to x squared plus 6x minus 5. Good luck.
When do you think my test will be graded?
Probably won't finish it until probably Friday or Saturday. So that means,
That's no problem.
yeah, you can pick it up like Monday, Tuesday, probably. Yeah, at the soonest.
Just need an A.
Well, that's what I'm going for. There we go. Okay, wait. So, okay, so why does that happen? Yeah.
And please give me the vertex too. If you guys can give me the vertex, please give me the vertex.
Can't we just do the? I do my notes. Okay. Let's use the amazing notes of God. Okay. So after this. Oh yeah, that's
You guys think you guys got an answer? You think you got an answer? yeah. Still, yeah. All right. When you think you got an answer, go ahead and have a seat and see what you guys get.
That looks right. That should be right. Yes. If you got it wrong, then it's your fault.
It's my fault.
Yeah, if we get it wrong, it's your fault.
Okay.
Wait, I wrote it wrong. Compared to everybody else, I'm right. It's so comfortable. He just gets it. You just I'm crossed on it. Okay, cool. That's actually really cool. I use
All right, guys. Go ahead and check your answer. Did anybody else get this? X plus 3 squared minus 14. Yes. Yeah, you guys got it. Okay, so tricky. What's my vertex going to be? Oh, I want to. Is there anybody else that wants to participate that has not participated? No. Yeah. Who have I not heard? I actually heard from Indigo a lot. I have not picking you a lot, Indigo. So Indigo, go ahead. Okay, so why is it -3, -14? That's correct. It's actually correct.
It's your fault. Yeah, it's your fault we got it wrong.
It's not my fault. See,
Wait,
good.
oh, because remember the 2. Okay, I see where you got it.
Is
One
hold on. Give me a.
Because in the last
I want to give it to Catherine because Catherine had her hand up patiently. Okay.
So when the value in the parentheses, if it's positive, since it's in the parentheses, it's going to change the value to a negative when you take it out. So it would be -3.
Okay. So remember, guys, that the standard form is x minus h squared plus k. So in this case here, if we have -14, if you want to rewrite it, it's technically plus -14 if you look at it that way, okay? And
the last equation was all like 2s, so I guess you can like see like what the difference.
Yeah, but now can you see like
Yes.
if the standard form is x minus h, and then this is written as x plus 3, you're actually technically subtracting -3, right? And then that should tell you right there. And if you rewrite your equation in this like vertex form, the way it should be written as x minus h, you're going to realize that your h is actually -3. Okay, counterintuitive to what you think. A lot of people do a shortcut. They say if it's +3, you got to think opposite. Okay, whatever's in the parentheses, you just think opposite. If it's +3, your vertex is -3, comma, whatever's on the outside. Okay? Yeah, does that make sense? Right? Does that make sense? All right.
Can you get anything else from doing that, or is that just all for the vertex?
That's for the vertex and the axis of symmetry. If you remember, the axis of symmetry is just this part right here. So if, like, let's say, for instance,
Just like which line it's on.
yeah, so if it's like a, I'm sorry. So really quick, wait, was this a, yeah. So if I drew a parabola, right? This would have been my parabola, okay? If I had, guys, okay? If this would have been my parabola, this would have been my vertex right here, right? Which is at -3, comma, -14, right? The axis of symmetry, yeah, the line that the vertex is actually on as well. So you literally just grab your x value, and it gives me -3. That's the axis of symmetry as well. So it gives you two different things, two features of the quadratic, a quadratic graph, okay, without having to do much work. Yeah. Yes, this is h. Yeah, that's your h, comma k. And if you want to look at it in a more general form, Sophia, than just x equals -3, it's technically just whatever your h is. X is equal to whatever your h is. Okay. You guys are really keeping me on my toes. Here's another scenario, though. We're almost finished. We're almost out of the woods for this section here. My hope is to get through 2 sections today, and then maybe make a video on section 3-6 or 4-1, I think, on a third section. Okay. Oh, sorry. Here's the subheading that we're gonna have. This is a.
Is it correct?
Yes, it is. Rewriting your function in vertex form.
Is this still 3?
Yep, this is 3, 4. Okay, in vertex form, when your a, we'll put lowercase a, is greater than 0. So we're going to see a scenario where a is going to be greater. Greater than not 0. When your a is greater than.
Is this 3-5? No.
This is still 3, 4. We've been on 3, 4 with the deception that I said it was 3, 5, but it's 3, 4. Okay. I've been deceiving you all. Okay. This is actually 3, 7. I'm just kidding. Okay. Here's a scenario. Here's a scenario where you're going to have your a greater than 1. Would you know how to?
I don't know.
Whoa, that's yeah.
Wouldn't
Duh.
you just put it
You
on
guys-
the outside? Because that's how it shows it in the form.
Sorry, no comma there, guys. Sorry, I'm making a bunch of mistakes with my whiteout here. Sorry, that's not intentional.
Someone should gift you those erasable pens.
That'd be awesome. Yeah, but they smear, so it'd be just smearing all over the place.
There was something where I think you can erase with like the back of the cucumber. What?
Well, I could be the big produce person. Like everyone, just bring me your cucumbers.
Like a lemon.
Something like
lemon
that.
like that, and then you put it over.
Yeah, you put lemon on a Q-tip and then you.
All right, I'm gonna stop you guys from your cucumber talk a little bit. Why don't you guys help me out with what would normally be your first step to changing this into vertex form? Yeah, and then you were gonna say too, Catherine. I want to add, yeah. Yep, just that. Putting what into parentheses though?
The 2x squared minus
Okay. And then maybe let's exclude the 17. Before we would just complete the square.
Wait, so that step's still right though, right? Because you said what did we do before, so we're still doing that.
Yeah, we're still doing that. But I'm sorry, yeah. The way I phrased that seems like I was going to give you something contradictory. But there is something that you might want to do first before we start completing the square like we normally would.
What do you do?
Okay, I haven't actually formally called Luciana for a while, so Luciana, go ahead.
Would you divide it by 2?
Divide it by 2 or...
Could you?
Well, why did you say 2?
Well, or you could like factor out 2 so that you would get x squared minus 6x instead of 2x squared minus 12x.
With that a being greater than 1, it does complicate things. So a good technique is just to factor out if they have common factors.
So x, 2x.
It's going to be 2. You're going to factor out 2, and then you're going to have x squared minus 6x, and you're still going to complete the square with what you have in the parentheses.
Are you not going to take the x out?
Oh, no. You want to keep it so that way. Yeah. So in this case, you don't get out the greatest common factor. You just factor out just purely numerical, not the variable, because we won't be able to complete the square without that variable being there. Okay. Because completing the square is just basically a method of rewriting your polynomial as a binomial that you can square. Okay. A like 2-term binomial that you can square. Okay. But that won't really happen if you take out the x as well. So you selectively take out just the number factor that you can take out. Okay. So in this case, you're going to take your b over 2 and square it. What is my b again? Thank you guys. Divided by 2. You're going to square that. Squared, which is 9. Okay. So I'm going to add 9 in here. And here's the tricky part. I will subtract something on the outside, but what is it going to be? Unbeknownst to a lot of people. It's actually not 9. Yeah, indigo.
Negative 9? Well, you'll be subtracting 9. If you add 9 to one side, you have to subtract.
Not quite, because
Oh!
does anybody see? Yeah, Sophia, hold on. Why did you get 18? It looks so deceiving because we forget about that 2 being there. When you add the 9, okay, don't forget that technically we factored out a 2 earlier, but whatever's in this parentheses, we are still taking that into account that you're not actually adding just 9. You have to take into account that 2 on the outside that's going to multiply to that 9. You're actually adding 18 to this guy, and you have to subtract 18 over here. So we have to ensure that's a fancy way of just adding 0, right? The positive 18 has to, cancel out that minus 18. So now you're going to have 2 times. Let's go ahead and rewrite this as x minus, or I'm sorry. It's x plus b over 2 squared plus or minus 1. And in this case, our b over 2 is, what's my b over 2? Just my b over 2. Negative 3. Okay. So if I write that in, it'll be minus 3 minus 1. And just to reiterate, my vertex form was technically a on the outside, x minus h squared plus k. What is my vertex going to be? Let's see. I believe it's a... Oh, I'm sorry. It's positive 3.
Oh, right.
Negative...
Isn't it 2 then? Yeah.
What do you mean?
The 2, doesn't it? 2 times negative. Or because it's the 18, would it already be canceled out?
Right here? No, so let's backtrack. We had 17 minus 18. That's negative 1. That 2 only distributes to what's in here. Okay? Not outside of the parentheses. So that still exists as negative 1. Yeah, Sophia? You would think so, right? But pay attention to just amount. Like your vertex is only KH, comma K, right? That number 2, that coefficient. I know it's really confusing. These rules sound very made up and arbitrary, like made up. But that 2 is now just an A. Okay, you don't multiply the A to the H when you're looking at the vertex. You just look at what's inside X minus H. Does that make sense? Okay, so that A stands like now that we finally got it in the standard form where you can clearly define what your A is, your H is, and your K. You don't have to have the A and the H mingle. H is just going to be -3 now. Okay, very confusing, but that's something maybe that's worth going to class to learn. Okay, that's a really fine point. Yeah, Indigo, did you want to add something else? Okay. All right. Okay, so that's it for that. Do you guys want to just do one so we could take a break from lecturing, or do you want to move on? What do you think? Petunia. What's your opinion? Yeah. No? Okay. Raise your hand if you want to move on to the next section. It involves me talking, or you guys want to try one now.
It doesn't matter.
It really doesn't matter.
If you go to the other lecture, I'll make things quicker. But if you do it, we'll
Learn more.
So
And learn how to do it ourselves.
Oh, okay. I can't beat that. So, dang. All right, fine. I'll give you one. Okay.
Future learner.
You guys are future learners. All right, everybody on the board. Go. You guys really like this whiteboard time, huh? I'm happy. I'm really happy you guys like that. That's really cool.
So y equals 2x. The chat out. Y equals 2x squared. No, we're not, because that's just 12.
That's good. That's really cool.
Yeah, that's not the one.
Oh, sorry. Don't judge me. Don't judge me. Okay. That was a trick. That was clearly a trick. Duh. Wow. Yep. I assume you kids all wanted a trick, so. And not only gave you a trick, I gave you something tricky. Ooh, dude. My suggestion is to factor out the negative as well to make it easier, okay? Graphing the inequality.
And then our version
Yeah. Ugh. Dr. Hibbert, you okay? Maybe. Maybe not.
Oh, yeah.
I feel smart.
You done did good, kids. Or did you?
Probably not, but I can say we did.
You got up and you did it. That's more than enough.
Okay, wait. It's not an A because
What's the answer?
He's gonna show us in just a second. It's a negative. Remember, the minus it.
I think that's so endearing.
I don't know. My brain is not working. Yeah, you're probably right.
And then you times the negative 4 times negative 2.
Dum dum dum. Dun, boom, 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 boom. Okay, your answer. Okay, that didn't happen, by the way. Okay, so yeah, no writing in this book. No, you silly goose, you. I would never do that. Yeah, someone else. Looks like someone else wrote in the book. That's so weird. All right, so you had to factor out a -2, which makes it really tough. Okay, because technically your A can be negative in standard vertex form. Sorry, in standard, not in standard form. Let's just call it in vertex form. It is technically, sorry, A times x minus h squared. You kind of want to ensure that your x, you don't have to, but it would really help to just make the x positive. Keep the x value a positive value. You don't have to, okay? But your A, however, can be just any negative number, right? It could be imaginary. I don't want it to be, but it could be. So in this case, I chose to keep the x in here by the end. I want to ensure that it's going to be like a nice positive value. So I factored out -2, or at least the publisher of this book did. Okay, so we factored out -2, and then it leads us to a long string of work that leads us to x minus 2 squared plus 5. What is our vertex going to be? Yes. Positive 2, comma, positive 5. Very good. Okay. I guess not. It's kind of redundant. Yeah, you don't have to. But you know what? No, I'm sorry. I didn't mean to say. You know what you said was redundant. Okay, no, that's not what I said. I'm just saying you don't have to. It's technically redundant. But what I love though is that you're emphasizing what you're. No, hold on. What Catherine's doing is she's emphasizing that it's a very common mistake for us to not take into account that it's either positive or negative. So what she's actually doing is trying to help out without even knowing it. You're just a good-natured person. So it's the little details, right? So thank you. You're so positive. Wow, good pun. Yeah, very good, very good. Okay. We are now moving on to finally you can look, all right, I'm not lying to you. 3-5 is quadratic inequalities, okay? Quadratic.
Are we gonna finish this section by something?
Probably not. I'm sorry. What? How much? Oh! Ooh!
Triggered.
I am. Okay. So we're gonna talk. Okay, we're gonna have to talk fast, aren't we? Yeah. Okay.
Are you not already talking fast?
No, this is the really round, like your speed. Okay. Okay. So I'm gonna show you how to graphing a quadratic. That's can't be right. A quadratic inequality. That's technically the I know. I'm sorry. That's really messy. Quadratic inequality. And then here's the example that we're going to do. Y is less than or equal to x squared plus 2x plus 4. So if I were you, I'd be shaking my boots because I'm like, I don't know how to graph that. Do you know how to graph that? I don't know how to graph that.
I thought we agreed with shaking in our shoes. No, I thought it was
Both. Everything. Yeah. Fayad.
You graph it like a regular equation, but when I don't know. So when it's less than or equal to, when it's or greater than or equal to, when you graph it, it's not it's gonna be like a straight line, but then it's like an open circle is only when it's greater than or less than if there's no equal to. But I can show you circle.
I think your brain's firing faster than your mouth can talk. Okay. One more person, because I really got to get this moving. Go.
It's not.
That's fine.
It's gonna be like a parabola, but if it's greater than or equal to or less than or equal to, then the line will be solid. But if it's just greater than or less than, then the line will be dashed.
Okay, so I want everyone's brain to just kind of be like, I'm grabbing at pieces of what they're saying. I don't get quite the whole picture that they're painting right now. Okay, even though in your brains it might be clear as day. Okay, most of us are, for one, might have a similar image in our head right now, but it's awesome for you guys to be on your toes to figure out what's going on because you're engaged. You learn a lot better if you're engaged. Okay, if you're not engaged, then you just sit there droning along. Okay, all right, Sophia, did you want to add something or no? Okay, all right, so you're absolutely right. You're just gonna graph. You're gonna graph initially like normal. And this is what I mean by normal. You're just gonna sort of graph this as if there was no less than or equal to sign. You're just gonna graph this like you normally would. Okay, so you have two options. You're gonna have to find the vertex. Okay, so find a vertex. Find the vertex. You have two options. You can either complete the square or you can do the negative b over 2a. Okay. For the interest of time, I personally think that x equals negative b over 2a is a little quicker. I think so. Okay. So I'm gonna take my b, which is negative 2, over 2 times a, which is technically 1. And that's going to be negative 2 divided by 2, and that's going to be negative 1. Yep, so that's my first part of my vertex. Okay, remember the vertex is not the axis of symmetry. It is on the axis of symmetry, but it's an actual point. So in order to find this y value, I would just plug in negative 1, okay, which is an x value, back into the equation. Yes. I'm not that quick. I'm sorry. I'm just not that fast. So you have to give me some time, okay? So it's going to be 1 times 1 plus, or minus, no, what am I doing? Okay, minus 2 plus 4. 1 minus 2. So I do apologize for the rapid pace right now. I'm firing, guys. I'm firing. Okay, fire. Okay. 1 minus 2 is a minus 1, I think. It's 4. I know you guys can solve this in a much fewer steps than I can, but
Wait, isn't that just...
whoops. And you guys get it right too. That's the difference. Okay. I got negative 1 comma 3. Anything else? Mine, what? You got negative 1 minus 3?
No.
Okay. Oh, I got negative 1, negative 3, but you guys got negative 1 comma 3, which is correct. Okay. So that's the vertex. You can already start graphing. So we got a vertex going on here. The book suggests to find 2 other points on your graph. So maybe on the bottom, give yourself a little bit of room to do some work for step 3, but simultaneously, let's go ahead and draw an axis somewhere on your paper or on the back of your page if you don't trust that you're going to give yourself enough room, okay? I'm going to dash it equal increments as best I can on each side of the axes meaning x-axis and y-axis. And then I'm going to put a point at negative 1 comma 3. Negative 1 comma 3 is going to be right here. I can expect a parabola that either opens up or down. Where do you think this is going to open towards? What do you guys think? Fayad, go ahead.
Wait, what's that question again?
Right here.
Oh, it's gonna be it's gonna open up because A is positive.
Okay.
If A is negative, then
Yeah, if my A was negative, it would be opening down, and my vertex would be the highest or lowest point on the parabola. It'd be if my A was positive. What if my A was negative and it opened down? It'd be the maximum point. Okay, so let's see. Okay, so we have to find 2 other points. Someone give me an easy point, like a x. Give me an x value. That's x equals 3. Anybody else want to give me another value? I don't want to do that. I don't want to do x equals 3. Yeah? Oh, okay. So you did x equals, I don't know. Oh, you just told me the y-intercept. Okay, so we can, okay, that, you know, I don't know, guys. I'm sorry. Sorry, Sophia. I need to show the work, so I can't just hop into that. Okay, let's do x. Let's just pick 2 other points, x minus 1. You have to plug it back into the equation. Y is equal to 1 times 1 squared plus 2 times 1 plus 4. That's equal to 1 times 1 plus 2 plus 4. That's equal to 1 plus 2 plus 4, and that's equal to 7. Okay? So that point is going to be 1 comma 7. So on your graph, plot that point 1. So on x equals 1, you go up 1, 2, 3, 4, 5, 6, 7. And then you have to plot another point. So it suggests in the book to plot 2 different points. We can pick another one. Negative. Oh, wait, we already have that. That's the vertex.
2.
All right. -2 it is. Then we're going to say 1 times -2 squared plus 2 times -2 plus 4. That's going to be 1 times -2, or 1 times 4, I apologize, plus -4 plus 4. That's going to be 4 minus 4 plus 4. Isn't that funny? That's 4 minus 4 is 0. Plus 4 is, what'd you say, Luciana?
So it's 4.
Yeah, so funny. We have -2, comma 4. So plot that. On -2, go up to 4. And then let's go ahead and connect the dots. So now we have a fully functioning parabola. Connect the dots in a U shape, okay, because we know generally that's what the shape's going to look like. Okay. Now, so far, what we've actually graphed is y is equal to x squared plus 2x plus 4. That's nothing new. But this is an inequality. You have to graph all the points that will be greater than y in this equation. How the heck are we going to do that? I'll say this. All the values on the bottom of this parabola will make this statement true, or the top, or atop the parabola. There's 2 choices and 2 sides to this parabola, okay? There's all these points over here because this, what you're actually graphing is not the actual parabola itself, but you're asking me what points on the parabola will give me this weird inequality where if I plug in an x value, it will be greater than it will be, yeah, if I plug in an x value on here, it's going to give me a value that's greater than my y. So guys, or equal to it. So guys, right now, I'm going to go ahead and stop you guys, okay? Because we're actually at the end of class, and I don't want to carry you guys on any further. This is going to have to continue on in the video. So I do apologize. There's going to be like 2 videos on 2 different sections, okay? All right, guys. Thank you guys so much, and I will see you guys next week. And for those that didn't get an exam back, please wait patiently until next Tuesday or Monday to get it back, okay? All right, guys. You guys take care and have a good weekend.